you, who does work at your house? Most of you would say your mom. She does dishes. You mow the lawn. Um, your little sister picks up the living room. But none of this is work in the physics sense. In physics, work is very specific. Work is what is accomplished when we have a force acting on an object through a distance. And so, in order to have work in physics, you have to have some sort of force moving an object through some sort of distance. Now, suppose you push a cart with a force, and we're going to designate work with this W. It's always a capital W. And the W is going to be the component of our force that is parallel to the distance traveled. Alright, so W is going to equal the force times the distance that's parallel. So if I apply a force to the right and my displacement to the right, then work is FD. It's very straightforward. So, work is FD, excellent formula, where F is the magnitude of the force and D is the distance. Now you remember magnitude just means number. We'll take our direction from our free body diagrams. So this is always going to be positive. Now work is a scalar. It has magnitude, didn't spell that right, but no direction. And we always measure work in Newton meters or joules. In this class, we're always going to use the capital J. Now, is work done in all of these cases? If I were to carry a stool across the room, well, if my displacement is to the right and gravity is straight down, then there is no force of gravity acting in the direction of my displacement. So, FG does no work. However, if I'm applying a force, okay, the work done by me is going to be my applied force times my displacement. What if I lift a stool up? Well, my applied force is in the same direction as my displacement, so my work is going to be positive. What about the work due to gravity? See, those are in opposite directions. So, this is going to be minus Fg times my displacement. My displacement is up, Fg is down. Now, what if I push down on the stool, but there is zero displacement? Then the work, which is force, times distance, well, if that's zero, the work is zero. So no matter how much I sweat pushing down on a stool, I'm doing no work. Kind of cool. Now, sign convention. Work is positive if F is in the same direction as D. Basically, work is positive if it's speeding an object up. That's another point. So there are two things you can look for. It's in the same direction as D, or if it's speeding the object up. Work is negative if they're in opposite directions, or if it's slowing the object down. Now, friction always opposes motion. It always slows down. So the work due to friction is always going to be negative. Always. Now, what do we do if we have forces at an angle? Well, the formula is work is your applied force times your displacement, how far it travels, times the cosine of this angle. So, this is a scalar component of the force acting through a distance d. Now, how do I want you to work problems? Work problems, that's kind of funny. I want you to write out your givens. I want you to draw a free body diagram. In part of that free body diagram, I want you to draw your displacement. This will help you determine whether work is positive or work is negative, or even work is 0. If work will be positive when the force and the displacement are in the same direction, it's going to be negative when the force and the displacement are in opposite directions. That's a D, not an F. And it will be 0 when the force and the displacement are perpendicular. Now, let's imagine we have a table and I have a rock. And I've got the force of gravity pulling down on this rock. So I've got Fg is mg. And let's say there's some distance from the ground to the table. Let's look at the work in moving this rock around on this table. Remember, work is force through a distance. So, let's see. Suppose I have a force that is pointing down. So Fg is pointing down. If my displacement is down as well, my work, since they're both in the same direction, is positive. So this will be speeding up. What is a good example? Well, this would be if my force were Fg and it were moving downward, then the work done by gravity is positive and it is speeding it up. What if my force is upward, so I'm lifting up, my displacement is down, they're in opposite directions, so the work is going to be negative. What would be a good example of this? Let's see. Something is falling downward, but it's being caught in a net. Then the net is slowing it down, and the work done by my force is negative. Suppose my force is downward and my displacement is up. So this is a good example of what happens when you have Fg, but you're moving up. So you're going up an incline. In that case, the work done by gravity is negative and gravity is slowing you down. So if I toss a ball up, my displacement is going to be positive, but the force of gravity is down. So gravity is doing negative work on the ball to slow it down. And finally, if my force is up and my displacement is up, so I'm lifting up and I'm moving up, the work done is positive.